Whenever you all are ready, could you explain what you've put together?
Sure. This is our FHP last gas model simulator, and we built this program to simulate behavior of gas particles on a VGA screen. We store our data by pixel, so we have 640 by 480 pixels, and in that model we have defined 6 directions, which are 4 diagonal directions and 2 horizontal directions. So we basically could store 6 particles per pixel, and so the maximum number of particles we can store is 480 by 640 by 6, which is almost like somewhere near 2 million.
Oh my god.
And we were able to animate this at 30 hertz on screen.
That is bananas. Okay.
Okay, so now we can show you some, we're controlling the initial conditions and pause or zoom using the switches.
Okay.
We have
the 7
switch
yeah, we have
for
the
direction,
we
and
have,
two switch for the dimension of the initial state. And this is the pulse. For this one, we use smallest dimension to start, and for the A direction and D direction, which is the left up and right down.
Okay.
and the 7-segment display is showing the number of particles in hex.
Okay.
I'm not sure how many that is.
Okay. And for now, this is sorry. This one is the triple collision, which is like A, C, and
E.
Direction, which is left up and left down and right. This 3 direction to start.
To start, okay.
Yeah, it's like
So
every particle collide with each other and just start bouncing off like
okay.
2 different directions.
So these are getting all mixed up here.
Yeah.
So just to make sure I understand, each of these particles can move up, down, left, right, and on the diagonal directions. Is that correct?
No, there are like 4 diagonal directions and a horizontal.
Oh, okay.
Yeah.
Okay, understood.
There's no vertical.
60 degrees.
Yeah.
Okay.
Yeah.
Okay. And then, can you help me understand what happens when particles collide?
Yeah. So they basically check what are the directions of all the particles on the same pixel.
Okay.
And they have a certain set of rules to decide if, say, like if we have
A and D.
2 directions, like A and D, and they will randomly go to 2 other outcomes.
B and E, or maybe C and
They
F.
shift
We have
themselves
a
by 60
random
degrees.
generator to
Okay.
decide
Yeah.
which way to go.
Okay. Okay.
They basically shift them by 60 degrees. And,
Yeah.
So to update the screen,
Mhm.
is the order of operations that each particle goes from its present pixel to the next pixel and then checks what other particles are at that pixel and their directions of travel to compute whether they need to change their own velocity? Or could you just sort of walk through how
Oh yeah.
an update works?
Of course. So it's pretty much so our implementation is pretty much like the drum
The
lab.
drum
We have
lab. To
300
calculate each column on the screen.
320 columns that have been that are parallel, like that are in parallel,
Okay.
and they calculate row by row. So
Yeah.
we first have like a collision state where we detect collisions and calculate what is the outcome,
Okay.
and then we
The outcome
enter
direction.
then we enter a propagate state. So we basically update the particle.
To the destination pixel.
Okay. Okay.
So it's for each pixel, it will have 6 input, which is the left up, left down, right up, and right down. So these pixels
direction after collision can be the input to the one we are calculate. So this pixel will knows who will comes to me.
Okay.
Yeah.
Okay.
That's the propagate.
And that's where we handle the boundaries and stuff.
Yeah. Also in the propagate.
Okay. And is this 2 million-ish particles that we're looking at here?
No, actually, if we hit 2 million particles, that's gonna be like, because
Oh.
every single pixel is filled with particles in
Sure,
in
yeah.
every direction, so we can't actually see any
Okay.
see any
Makes sense, yeah.
behavior. But there's definitely some interesting things we can go with that.
Yeah. Okay.
Wow.
Like that's more pixels.
And the behavior of the system and how they converge actually, like, it really changes depending on the initial conditions.
Yeah, and we can also do fixed particles on that horizontal band.
Oh, and the color is
How many
reflecting
pixels on?
the
How
density.
many particles on that pixel?
Okay, okay,
So white means there's only one, and like
No,
the
orange
orange
is
is
six.
six.
okay. So we just saw there was a band of orange in the there's a band of orange in the middle, so there's a lot of high density particles or high density cells in the middle, and now those high densities have moved to the top and bottom with low density in the middle. So it's sort of oscillating and diffusing a little bit, it looks like. Wow. Very, very nice. And is this all FPGA? Is the HPS doing anything in here?
No, it's all FPGA.
All in the FPGA. Very impressive. Sort of hypnotic. Cool. Thank you all.
Yeah, thank you.